Hello, everyone, and welcome. Today, we're going to dive into the absolutely incredible story of chemistry. We'll trace its journey from these mysterious ancient labs all the way to the science that really shapes our entire modern world.
So let me start by asking you a question. Just think for a second about the medicines in your cabinet, the paint on your walls, even the soap you used this morning. What's the one single, invisible thread that connects all of them?
You got it. It's chemistry. It's the science of matter. What stuff is made of, why it behaves the way it does, and how it all changes. It's literally the science that built the world we live in.
And what's wild is just how much it's woven into our lives. From the fuel in our cars, that's petrochemicals, to the plastics in pretty much everything we own, and of course, the medicines that keep us healthy. These are all products of chemistry, working for us every single day. So where did all this knowledge even come from? Well, for that, we need to go back in time.
Let's jump in our time machine and travel way back to the Islamic Golden Age. This was just a shining era of scientific discovery, and it really set the stage for chemistry as we know it. For almost 1,000 years, think about that, from 600 to 1600 AD, alchemists in the Muslim world were making these incredible advances. They weren't just rehashing old ideas, they were building the very foundation for a whole new science, one that would literally change the world. So what were these alchemists even trying to do? Well, they had 3 gigantic goals. You can think of them as the moonshot projects of their time. Figuring out how to prolong human life, trying to turn cheap metals like lead into pure gold, and finding actual physical proof for their beliefs. Now, they never did manage to turn lead into gold, but in trying, they did something way, way more valuable. They invented the modern scientific lab. And that brings us to 2 absolute giants of this era. These are the scientists who really transformed alchemy from this kind of philosophical art into a true experimental science. First up, meet Jabir ibn Hayyan. If you're looking for the person who put the science in chemical science, this is your guy. He's widely considered the father of modern chemistry, and it's for one absolutely crucial reason. So what was Jabir's big idea? It all came down to one thing: experimentation. He was the first to have a proper, well-established lab, and he invented so many of the core methods we still use today, things like distillation, filtration, and extraction. These weren't just random tricks. They were systematic ways to finally understand and control matter. Next, we've got Muhammad ibn Zakaria al-Razi, another heavyweight from this period. He was a brilliant physician and a chemist who took Jabir's hands-on approach and added another critical element: systematic organization. You see, al-Razi was a master classifier. In his famous book, Al-Asar, he was the first person to start grouping chemicals into different types and to separate substances based on whether they came from living or non-living things. This whole act of sorting and organizing the chemical world is a fundamental part of how scientists still work today. He was basically drawing the very first map of knowledge. So where did that early map lead? Let's fast forward to today and take a look at the modern map of chemistry that grew directly from the foundations laid by pioneers like Jabir and al-Razi.
Today's chemistry map is divided into several major branches. Each one is a different path to understanding matter, and you can see how they're all connected. Think of them as different specialties, all working on the same grand project. Let's explore a couple of them. First, we've got organic chemistry. This is the chemistry of carbon and hydrogen. And because those two are the main building blocks of life, this field covers everything from the plastics and fuels we use to the very molecules that make you, well, you. It's a direct line from the alchemist's quest to understand the substances of life. Then there's what I like to call the detective branch, analytical chemistry. Its whole job is to figure out 2 things. What is this stuff made of? That's the qualitative part. And exactly how much of each ingredient is in there? That's the quantitative part. This fulfills that ancient need for proof, for a way to really know what you're working with. And that leads us straight to biochemistry, which is the chemistry of life in action. It studies the ridiculously complex chemical reactions that are happening inside every living thing, including you right now as you're listening to this. This is probably the clearest modern version of that ancient quest to prolong life. Okay, so these branches aren't just abstract ideas for a test. They're powerful toolkits we use to solve real-world problems. Let's look at a couple of quick examples. Here's a question that affects every single one of us. How can we be sure that the water we drink is safe? How do we find out if there's some kind of impurity in it, and exactly how much? The answer is analytical chemistry.
Remember our detective branch? Its tools and techniques are precisely what we use to detect and measure impurities in our water, making sure it's safe for us all to drink. It's basically chemistry acting as a public health guardian. Or how about this one? When a doctor needs a new medicine to help a patient with something specific, like a thyroid problem, how do scientists even begin to develop that drug? That is squarely in the domain of biochemistry. To create a medicine that works, you first have to understand the complex chemical reactions going on inside the body. Biochemists provide that crucial understanding, which then allows us to design drugs that can actually help restore people's health. And that brings us perfectly full circle. I want to leave you with one final thought. The ancient alchemist had this grand, incredible ambition to prolong life. Looking at the modern map of chemistry we just explored, which branch do you think is carrying the torch for that ancient quest today? It's a fascinating question, and it just shows how far we've come and how the dreams of the past are still powering the science of the future. Hello, everyone, and welcome. Today, we're